section 2.
The next one is the elimination method. So the previous one is the substitution method. The way is, the first thing is solve for y, or it doesn't need to be y, but like the solve for either x or y. So for this case, we use a y equals 2x minus 1. After getting this, we plug in this y into this, which is a substitute y. That is a substitution. Now, instead of this, we can do the elimination method. We can cancel, we can eliminate. So we can eliminate either x or y. So let's see which one is better. So we have a 5x plus y equals 4, and we have a 3x plus 2y is equal to 1. Now, if we make, instead of just y, if this is a 2y, we may cancel, we may eliminate the y part. So let's multiply by 2, which is a 10x plus 2y is equal to 8. So we multiply by 2 on both sides for the first equation. And just leave the second equation as it is. So we have a new equations, but they are the same as before. Now we want to eliminate the 2y. How can I eliminate? Well, the way is we subtract from the first equation to the second equation, but only on the left-hand side we subtract the left-hand side component to the left-hand side component, and the right-hand side component as the right-hand side component. So we subtract means we subtract the 10x plus 2y minus 3x plus 2y is equal to a minus 1. So the left-hand side, which is this, minus the left-hand side, another left-hand side. And then for the right-hand side, we subtract 8 and 1. And when you simplify this, we have a 10x plus 2y minus 3x minus 2y is equal to 7. We have the 2y and 2y, we can cancel them. We have a 10x and we have a 3x, which is a 7x, is equal to 7. So we can get the x as 1. Now once we get an x value, we can plug in either the first equation or the second equation. So if we use the first equation, we have 5 times 1 plus y is equal to 4, which is a y. This is a 5. So y equals 4 minus 5. So we get a negative 1. So the solution is 1 comma negative 1. That is a solution. So that is an elimination method. We eliminate the y component. Now we can eliminate the x component if we like. So, any questions so far? Is that too simple for you? Or?
Oh, it's simple, but it's always the memorization of the different types of methods, you know, and memorizing the formula and knowing how to apply it.
You can use just one method. You can stick to the one method if you like. You don't need to use two different methods.
Yeah, I'm just saying that we have so many different kinds of methods, so many different types of problems. So if I do this right now, it's no problem. You come back to me later after doing 10 other different kind of problems, and I'm like, oh man, what was that method?
So what I can do is, let's use, for this one, instead of eliminate the y component, let's try to eliminate the x component. So we have a same 5x plus y equals 4 and 3x plus 2y is equal to 1. So let's remove the x component. To remove that, 5 and 3, they are not the same, so we have to match them. To match them, what I can do is we find the least common multiple of this 5 and 3. What is that?
15.
15. So to make a 15, we multiply by 3. And we multiply by, for this one, 5. Then we have a 15x plus 3y is equal to 12. We have a 15x plus 10y is equal to 5. Now we subtract. So when you subtract that, I'm not going to rewrite as this minus this. We can just do subtract. So subtract means we can cancel them. And we subtract the 3y minus 10y. And then we have a 12 minus 5, which is a negative 7y is equal to 7. So we get a y equals negative 1. Once we get a y value, we can plug in, then 3x plus 2y is equal to 1. So 3x minus 2 is 1. So 3x is 3. So x is equal to 1. So we still get the same solution. 1 comma negative 1 is a solution. Now the last step. Check the solution. I'm sure that most of the case, your solution satisfies the both equation, but may not be. If you made some algebra mistake, then you get the wrong solution, obviously. So the check means plug in into the original equation. So we have an original equation as a 5x plus y equals 4, and 3x plus 2y is equal to 1. So plug in 1 comma negative 1. So when you plug in 1 and negative 1, so 5, 1 plus negative 1. Check that whether this is a true statement, and then 3 times 1 plus 2 times negative 1, whether this is also a true statement. I think they are the same. 5 minus 1 is a 4, and 3 minus 2 is 1. So they are true statement. That means your solution, 1 comma negative 1, is a solution. Most of the case, I don't check that, because I know that my solution is correct. But your solution may be wrong, so you have to check that. Okay, now let's do one more. So 3x minus 4y equals 1, and 2x plus 3y equals 12. Now we have we can either remove the x component or y component. It doesn't matter. So let's remove the y component. You can choose x, it doesn't matter, as I said. If I want to remove the y component, then I have to make the 4 and the 3 as the same number, so which is 12. So I multiply by 3 and multiply by 4, so which makes we have a 9x minus 12y is equal to 3, and then we have 8x plus 12y is equal to 48. Now instead of subtract, I can just add them together. When I add them together, the reason is I have a negative 12 and plus 12. The way to eliminate the negative 12 and the plus 12 is just add them together, right? So if I add them together, I can eliminate the y component, which is a 9x plus 8x, which is a 17x, and 3 plus 48, which is a 51. Then x is a 3. Once I get x value, so plug in either into the first or the second. Let's plug in into the second. Then 2 times x plus 3 times y is a 12. So 6 plus 3y is a 12, which is a 3y is equal to 6. So y is equal to 2. So the solution is 3, 2. And that is the solution. And also, check the solution. I'm not going to check that, but try to check the solution. Plug in 3, 2 into the equation and make sure that it satisfies the both equations. Any question? All right, let's continue. So we have 4x plus y equals 2 and 8x minus 2y equals negative 4. Now let's try to eliminate the y component. So to do that, I have to match this plus 1y as a negative 2y. So I can multiply by 2. Then I have a negative 8x plus 2y is equal to 4 and 8x minus 2y equals negative 4. Now let's add them together. When I add them together, I have negative 8x and plus 8x, plus 2y and negative 2y, and plus 4 and negative 4. So all the components are cancelled out. So which is 0x plus 0y is equal to 0. Isn't it? So the left-hand side is 0 all the time, regardless of x value and y value. And the right-hand side is also 0. I can plug in x equals 1, 2, 3, 4, 5, or radical 2. It doesn't matter. It is always 0. And the right-hand side is also always 0. That means what?
0.
0? Do we have a 0 solution? There are infinitely many solutions. Because I can plug in any x value and y values. But still, they are equal to each other, right?
So is that the graph of the two lines on top of each other?
That's right.
Yeah.
So, infinitely many solutions, and then the system is, well, I'm not going to say that the system is consistent, etc. So instead of that, we have one equation instead of two different equations. And from here, I can get y equals 4x plus 2, which is a straight line. Now, straight line is infinitely many solutions, infinitely many points on the line, especially when x point is given as x, and then y value is 4x plus 2. And this is x comma 4x plus 2 is the solution for any x value. So whenever the x value is given, we can compute the y value. That is the solution. Whenever we have a different x value, if we plug in 4x plus 2, that is another solution. So we have infinitely many solutions.
Basic question seems obvious, I guess. Mm-hmm. How is 4x plus 2 plottable? I mean, how does that make any sense in the real world?
Okay, so
as a point on the graph.
So what is x comma 4x plus 2. Let's say we have x is a 0, then we have a 2. And we have a 2, x is a 2, then we have 10, right? So we have 0, 2, which is here, and 2, 10, which is around here. So we just plot the point, all the point. If you plot all the point, infinitely many point, I only plot the 2, but there are infinitely many in between, right? Then this, all point, this is a line, but the line consists of infinitely many points, right?
So 4x plus 2 is nothing until I figure out x,
That's
that
right.
I can get a point on the graph.
That's right.
Yeah.
So, or the other way is whenever you have an x value, you can get the y value.
Right.
Now 3x minus 4y equals 4, 2y equals 4, and the negative 6x plus 4y equals 7. Now let's remove x component. We can do the y component, but let's do the x component. Now let's multiply by 2, which is a 6x minus 4y equals 8. And then we have a negative 6x plus 4y equals 7. Now let's add them together. Now when you add them, we can cancel and cancel, which is a 0x plus 0y is equal to 15. The left hand side is 0, but the right hand side is 15. There is no such x and y. The 0 cannot be 15, right? So there is no solution. The reason there is no solution is these two graphs are parallel to each other. So they are parallel to each other like this. So they never intersect with each other, so there is no solution for the system.